Exercise 10. So, g of x equals a times x squared plus 24. For the function g defined above, a is a constant and g of 4 equals 8. What is the value of g of minus 4? Okay, so here we have one unknown. This is this a. And to be able to calculate how much is g of minus 4, let's use our first information, g of 4 equals 8. This will give us an equation with only one unknown, a, and we will be able to find this unknown. So, g of 4 equals 8. So, 8 equals a, and we substitute 4 for x, so we get times 4 square plus 24. So now we can subtract 24 and we get minus 16 equals 8 times, and 4 square is 16. Now we divide by 16 and we got a equals minus 1. So our function g of x has a formula of minus x squared plus 24. Now if we want to calculate g of minus 4, we have to substitute minus 4 for x. So we write minus, then open the bracket, minus 4 square plus 24. And what do we get? We get minus 4 square equals 16. So we write 16 plus 24. And minus 16 plus 24 is 8. So this is answer A. Here it's important to remember that this power works only on things that are in a bracket. And if there would be no bracket, it would only square this number 4. Minus would not be part of this squaring. So if you want to calculate the power of a negative number or of a fraction, you need to put this in a bracket. Okay, so here we have answer A, and let's go to the next question. So exercise 11. Oh, that was here. So B equals 2.35 plus 0.25x, C equals 1.75 plus 0.40x. In the equation above, B and C represent the price per pound in dollars of beef and chicken, respectively, X weeks after July 1st during last summer. What was the price per pound of beef when it was equal to the price per pound of chicken? Okay, so we want to know what was the price when B equaled C. So we can substitute those formulas for B and C, and we got 2.35 plus 0.25x equals 1.75 plus 0.4, maybe like here, plus 0.4x. Yes, this 0 in the end doesn't change anything, so we can just not write this. It's important to know that from this equation we will calculate x. X is not the answer. X is weeks after July 1 during last summer. So it won't be the answer, but if we will have x, then we can substitute for x the number that we got here, and this way we will calculate the price of beef or chicken. It doesn't matter because they are both equal for this particular x. Okay, so I would put x on the right and 1.75 on left. 2.35 minus 1.75, it's 0.6 equals 0.4x minus 0.25x equals 0.15x. Now we divide this by 0.15. We've got 0.6 divided by 0.15 equals x. Okay, so we can just move the comma by the same amount of places in numerator and denominator. So I would move this for 2 places on the right, and the same I have to do in the numerator. So in numerator there will be 60 and in denominator there will be 15. 16 divided by 15. Oh, now I can simplify this by 5 or by 3. It will be 20 divided by 5 and 20 divided by 5 is 4. So for x equals 4, the prices are the same, which means that 4 weeks after July 1st, the prices of beef and chicken are the same. And now we can calculate them. So for example, let's take beef. 2.35 plus 0.25 times 4. It is 2.35 plus, and here it's 1, so it will be 3.35. So the answer is D. Of course, we can check. Yes, chicken, the price of chicken, it will be 1.75 plus 0.4 times 4. It is 1.75 plus 1.6. And if we zoom this up, we will get 3.35. So we see the same price. One maybe remark here. I'm saying 0.25 and yet I'm using comma instead of dot. Well, it's so in United States and I think in all these Commonwealth countries, people use dots to point out where the fraction starts of a number. But in continental Europe, and I don't know how the rest of the world, but in continental Europe, I think we use commas instead of dots. So, well, maybe it's dots may be nice, for example, if you are writing vectors. If you want to write vectors in this Commonwealth way, you can, for example, write its coordinates like 3.4, comma 5.6. You can just use comma. But in European style, you have to write 3, comma 4. And now here, if you put comma, it's problematic because it looks like 4 numbers different. So for example, I'm using semicolon instead of comma in this kind of situation. Although I'm not sure if that's how it should be written, but to make this difference between those two numbers in coordinates of vector, I'm using semicolon. Okay, so exercise 12. Let's go maybe this way. A line in the xy plane passes through the origin and has a slope of 1/7. Which of the following points lies on the line? So basically what they say here, it's we can draw this. Origin of plane xy, of xy plane, it's the point where axes intersect, which means point 0, 0. So our line goes through point 0, 0 and has a slope of 1/7. Slope of 1/7 means that if you move by 1 on x axis, you have to move by 1/7 up on the y-axis. So, another way speaking, if you will move by 7 on x-axis, you will move by 1 on y-axis. So it also moves, so our line also goes through point 7.1. So this is our line. Well, maybe something like this. Maybe a little bit higher. Oh, yeah. I think it should be lower here. Okay, and now 2, 4, 6, 7, and here it should be on 1, so a little bit higher. Oh, yeah. This is our line. Which of the following points lies on the line? Okay, so we can try to just look on this drawing and tell which one. For example, 0.7. 0, 7, 0, 7 is 2, 4, 6, 7. 0, 7 is here. So answer A is definitely not right. Answer B, 1, 1, 7. So 1, 7 here. Definitely not. 7, 7. 7, 7 is here. Once again, not. And 14, 2. Here is 7, 1. And once again, 2, 4, 2, 4, 6, 7, 1. Once again, we moved by 7 on x-axis to the right and 1 on y-axis up. So yes, it will lie on this line. So it will be answer D. But we also do not need to just look, especially that here it was easy. Those points definitely do not lie on the line. But what if our points look like this? Like very, very close to the line, but maybe not on the line. We would have a problem because how sure are we that our drawing is exactly good, exactly going into the through the points that it should go. Also, some points might be hard to draw in a proper way. Maybe you will be not sure if it's on the line or maybe a little bit up on the line, above the line, and so on. So, of course, we do not have to. We can just calculate this. Because if our line has a slope of 1/7, this means that its formula is y equals 1/7 of x times x plus some b. But if it goes through the origin, we know that b is a y-coordinate of a point of which x-coordinate is 0, that our line crosses. So for us, this point is 0, 0, which means that b equals 0. So exactly our line has a formula of y equals 1/7 times x. So now we can just put those points into this formula and look if they match this equation. So for point 0.07, we got 7 equals 1/7 times 0. 1/7 times 0 is 0. That's not right. So this point doesn't lie here. The same for B. We will have 7 equals 1/7 times 1. 1/7 times 1 is 1/7, so it's not 7. For C, we will have 7 equals 7 times 1/7. It simplifies to 1, but it's still not 7. And for 14, 2, we got 2 equals 1/7 times 14. It simplifies by 7, so it is 1, and here it's 2. And 1 times 2 equals 2, and that's okay. And now, even if you will have points that will lay very close to this line, by calculating, you can be completely sure if they lay on the line or maybe they're just only close to the line. So that's definitely a better way to solve this solve this question. So here in exercise 12 we have answer D. Thank you for watching my videos. If you like it, please subscribe and turn the notification bell and do all this stuff that happy viewer does after watching a video. And well, have a good day. Bye.